Okay, welcome to part two. In part one, we discussed potential and kinetic energy. I gave you some examples with some pictures, and I gave you an example of a rock falling off a cliff. And we said that when the rock is at the very top, it will have 100% potential energy. It's not falling, it's not moving yet. When it's halfway down, approximately, it will be about 50% potential energy, 50% kinetic energy, because it's moving, but yet it still has height where it's still yet to fall. So all this height gives it or it shows that it has some potential energy remaining because it hasn't fallen through there yet. All right, so it changes. As it changes, it goes from 100% potential, less potential and more kinetic, less potential, more kinetic, less potential, more kinetic, until finally it lands on the ground. And then when it finally lands on the ground, or just about to land on the ground, it's almost 100% kinetic energy. Okay. And then we said that there's something called mechanical energy, that's the total sum of the energy of the system, that it's the potential plus the kinetic energy. And just to give you an example, let's say this is the rock here has 200 joules of kinetic energy. Okay, because of how far it is from the ground and how much mass there is and the force of gravity, it has 200 joules of potential energy. Joules, if we haven't spoken about it in class, is the unit of measurement for energy. And so let's say it's 200 joules potential energy, and so 0 joules kinetic energy. All right, and then over here, let's say as it falls, this is a J. As it falls, let's say it has less potential energy, 150 joules. So over here, it's going to have 50 joules of energy. And again, it's still going to equal 200. Okay, as we fall, let's say it gets halfway, and so it's going to have 100 joules of potential, and then 100 joules of kinetic, still equal to 200. As it falls even further, maybe it has 50 joules of potential and 150 joules of kinetic, but still it's going to equal 200 joules. Joules, don't forget your units, joules. So the fact that the mechanical energy stays the same and the energy is not lost within the system has to have a name. This is called the law of the conservation of energy, which makes a lot of sense. Conserve means to save. Conservation of energy means that the energy is saved and is not lost. So no matter what you do, the energy you put in is the energy that comes out, basically. The energy in the system doesn't change. So another way to look at it, let's say you're pushing, you're doing some work and you're pushing this big box, right? And so this box might require 10 joules of energy to push it. Well, then you're going to give 10 joules of energy. Now, actually, what you'll probably have to give is maybe, let's say 13 joules of energy to make this thing move, right? Now, why would that be? Because you have to fight something called friction, all right? So the friction plays a part in a lot of this. So the conservation of energy says that energy is never lost. Energy is never lost. All right. So we'll cut it short here, and we'll see you on part 3.